Good afternoon, all.
Good afternoon, ma'am.
Yeah, today's topic is computer arithmetic. We have seen data representations in fixed point. Floating point we'll see a bit later after arithmetic on fixed point data. So we know we are dealing with numbers, signed numbers, because our numbers can be positive or negative. So signed numbers we usually refer, which can be represented in three ways: sign magnitude, sign one's complement, sign two's complement. Okay. So when this type of data we want to give for a computer, so we will write several arithmetic instructions which are used for manipulate this data to produce your results. Okay. The basic arithmetic operations are addition, subtraction, multiplication, and division. Now these operations you want the computer to do. Okay. So with the help of the arithmetic and logical unit which is present inside the central processing unit, which is take care of performing the arithmetic operations, right? On the specific type of data that may be a fixed point or floating point. Okay. So now we will develop an algorithm which says how the numbers need to be operated based on the specific operation. Okay. So we first deal with fixed point data. Fixed point data, that too signed numbers. Okay. For all these operations, to perform all these operations on fixed point data, okay, you have to develop an algorithm from which I need to build the hardware which is responsible for performing the operations. Okay, right? So now we start with addition with fixed point data. Okay, we know under fixed point we have three ways to represent: sign magnitude, signed one's complement, signed two's complement. There is no much difference between signed one's complement and two's complement. Both the ways it is one's complemented and add one to the result in two's complement. Okay. In both the cases, the problem we have removed the problem of separating the sign and performing the operations, which was there in sign magnitude data. Okay. So first we develop the algorithms on sign magnitude data. After that we see sign two's complement data. Okay. So numbers are represented in sign magnitude form. Okay. So we want to perform addition. Let us suppose there are two numbers A and B. We have two numbers which you want to perform the addition. Okay. So whenever I say two numbers,
Ma'am.
yes.
Ma'am, the screen is not visible, ma'am.
Okay, sorry. So whenever I say two numbers A and B, and we are talking about sign magnitude form, okay, sign magnitude form of data. So it is having sign and magnitude. Okay. So let us take in sign magnitude form, it is clear that sign has to be treated separately and magnitudes has to be treated separately. So let us suppose my datum. So, I may want to perform an operation of with my A, where A is let it be plus A. Okay. And some addition I want to perform on another number which is B, that is also let it be plus B. Okay. So this operation I want to perform because I may come across 4 different ways, right? So my A can be plus A, B can be plus B, or else A can be plus A, B can be minus B, or my A can be minus A, B can be plus B, or else both are negative numbers. Am I clear? So whenever I said that I have 2 numbers on which I want to perform my addition operation, the numbers can be both positive, or first number positive, second number negative, or else first number negative, second number positive, or both the negative numbers. Okay. So whenever I want to perform an operation like this, plus A within brackets to confirm. And second number is also positive. Okay. So if this is the condition, then what is the result of operation? Result is positive and sign of the result is positive and its magnitude is A plus B. Am I right? Right? So this is what operation we are performing on magnitude. I am performing addition operation on magnitudes A and B, and the result is getting a sign of positive because both the input numbers are positive, right? Let us take the second possible case where my first number is plus A and my second number is minus B. Okay. So in this case, what is the result of operation? Result of operation with respect to magnitudes, can anybody tell me?
A minus B.
A minus B. And what is its result of sign of the result?
It's the sign of the greater of either A or B.
Yes. Okay. So to perform the operation now, you should know which of the numbers have the magnitude more. Okay. You have to compare the magnitudes and then you need to decide the operation whether B has to be subtracted from A or else A has to be subtracted from B. Okay. So you read now a comparator which checks the condition, right? Okay, so you require a comparator that will says if my A magnitude, A refers to magnitude only, A is greater than B, then what you will perform? You will perform A minus B because A is greater than B. Okay, and whatever is the sign of A, because A is bigger, whatever is sign of A, that will take the resultant sign, right? So now the operation is A minus B and the result is plus because A has a positive sign. Okay. If A is greater than B, if A is lesser than B, what operation I will perform? I will perform because B
B
is
minus A.
higher magnitude. So B minus A I will perform. And what is the sign? Sign of the result? Whatever it is the sign of B,
Minus.
that will be taken for consideration. Okay. So minus of B minus A. Right? And what is the third output of the comparator? A may be equal to B. Okay. So if A is equal to B, I will perform A minus B, and obviously it is clear result is 0. And in sign magnitude form, we have 2 representations for 0, plus 0 and minus 0. So to avoid that ambiguity, you have to develop an algorithm which will consider only one, which will result only one type of 0. Okay, that too we are taking positive 0. Okay, so without having any ambiguity in the result, we write an algorithm in such a way that the result is always a +0. We will eliminate occurrence of -0 while developing the algorithm itself. Okay, so this is the situation when we want to add two numbers out of which one is positive and another is negative. Similarly, the third case where I want to perform addition of -a with another number plus b. Okay. So now what is the condition? So here obviously, here what is the operation that is performing? Though we wish to perform addition, here actual operation is subtraction. Okay. So these three, they perform subtraction. Am I right? Because of the sign of the numbers. Now it is -a and plus b. So I have to perform b minus a or a minus b based on the comparison, right? So if a is greater than b, what should I perform? I have to perform a minus b. And what is the resultant sign? Whatever it is sign of a, that will result the resultant sign also. Minus of a minus b. Am I right? And what is the operation here? B minus a, the result is plus b minus a, because the sign of b, which is nothing but complement of sign of a. Okay. And what is this? It is just a minus b or b minus a we can do, but we are eliminating -0. So everywhere we perform a minus b with the plus only. Clear? And last case,
Yes, ma'am.
minus of a and plus minus of b. So what is the operation? Both have negative sign. The operation is minus of a
Addition.
plus b. So it perform here addition, not the subtraction. Okay. So these are the four possible data items that may come for addition. Okay. In first case, both are positive. So the operation is addition and its sign is positive. Okay. In fourth case, both are negatives. Operation is addition and the sign is negative. It means if I have two numbers whose sign is the same, if the sign is the same and the operation is addition, okay, and if you want to perform addition, so the magnitudes are added and the result sign is equal to the sign of the inputs, right? In 2 and 3 cases, the sign of the two numbers is different. Okay, sign of the two numbers is different and you want to perform addition operation, then actual operation is carried out is subtraction. Okay, based on the magnitudes of the numbers, it can be either a minus b or b minus a. And what is the resultant sign? Which is equal to the sign of a if a is greater than b, or it is complement of or sign of b if a is lesser than b. Am I clear in both the cases? Right? Since for
Yes, ma'am.
addition operation, we may perform either addition or subtraction. If I want to perform subtraction, I may perform sometimes addition, right? With this, it is clear. So I can add even the subtraction conditions also here. Okay. So I can develop same algorithm for addition and subtraction. Right? So now take the same 4 possible cases for subtraction. Now I want to perform subtraction between these data. Now tell me what is the result. Okay. See, plus A minus of plus B. So result is result of operation either addition or subtraction.
Subtraction.
Subtraction. And that too it is A minus B or B
A minus B.
That is depending on comparator output again. If A is greater than B, then result is a plus of A minus B. Right? If A is lesser than, the result is minus of
B minus.
minus A. If both are equal, we force to get a positive result. So I'll be getting plus of A minus B. Okay. Here, in second
Addition.
case, it is A plus B. Because A plus A minus of minus B, it will become addition. A plus B. In third case, minus A minus of
Addition.
plus B. So I may perform A minus B. This is only B result, right? Am I right? It is minus of A minus B or
Ma'am,
B minus A. When
ma'am,
both
it's minus A minus B, no, ma'am.
yes.
It should be addition, no, ma'am. Minus of A plus B.
Yes. Okay. No, not this case. Okay, sorry. Minus A minus of plus B. It is nothing but minus of A plus B. Minus of A plus B. Okay. So this case, this is what the result, I think. Right? Minus A minus of minus becomes plus B. So I may get minus of A minus B if A is greater than B, or else plus of B minus A if B is greater than A. If both are equal, plus of A minus B. Right? So what is the condition in subtraction? So here my operation is subtraction and the sign of the two numbers is same. Here also. The operation is subtraction and the sign of the two numbers is same. Then actual operation is performed is either A minus B or B minus A, whose resultant sign is same as sign of A. Sign of A if A is greater than B, and the resultant sign is complement of a sign of A if A is lesser than B. Complement of a sign of A. Okay, see, because both are same signs, right? If A is greater than B, positive resultant. If A is less than B, negative is the result. So I have to take complement of sign of A. And in subtraction, if both the magnitude, if both the signs are same, the operation is subtraction. Okay. If both the signs are different, the operation is addition in case of subtraction. Am I clear?
Yes, ma'am.
So there are possible 8 cases are involved whenever you perform either addition or subtraction of two numbers which are represented in sign magnitude form. Okay, these are the possible 8 cases and the result we are expecting like this. Okay, right? See, it is very simple. For example, you have given, you want to perform an operation of addition between 6 and minus 7. What you will do? Addition operation 6 plus of minus 7. Because it is negative number, it is positive number. So I will subtract 7 minus 6, which is nothing but 1. And 7 is bigger, so that sign will be taken by my result. -1 is the result. Okay. So the same procedure, whatever we are doing manually, that we have represented with A and B refers as magnitudes. Okay. The same procedure, manual procedure, we have represented in the form of a table. Okay. Now you want to perform this logic with the help of your hardware, your computer. So now you need to conclude what is the hardware required to perform this particular operations. Okay. So for implementing it in hardware implementation, what is the hardware required? Can anybody tell me? See, by observing the table itself, it is clear. First, I have two numbers, right? So I may perform addition or subtraction. Subtraction is A minus B or B minus A. Okay. So I have to perform addition of two magnitudes. That's what A plus B, or I require to perform A minus B or B minus A. These are the three operations that are existed in this diagram, right? So to perform this operation, A plus B, I require an adder, right? Okay. Depending on
Yes, ma'am.
the number of bits in your A, I require that many bit adder. If it is 4 bits, then 4-bit parallel adder, or 8-bit parallel adder, or 16-bit parallel, depending on the number of bits, number of bit computer is. Okay. So I require a parallel adder. To perform A plus B, and similarly a parallel subtractor, right? One parallel subtractor to perform A minus B, and another parallel subtractor to perform B minus A, right? With the same A minus B, with the same one parallel subtractor, I can perform A minus B. I require one more parallel subtractor for B minus A. Okay. So to implement this in hardware, one parallel adder I require, two parallel subtractors, and how I get this decision? A greater than B or A minus A less than B, or A equal to B.
Comparator.
Decision, I require one comparator that compares the magnitudes, right? And then, is that sufficient? You require anything more?
No, ma'am.
No? Nothing? How would we know the sign relationship? The relationship between the sign of two numbers, based on which you will decide whether it is addition or subtraction, right? If both the signs of the numbers is same and the operation you want to perform addition, then you go by addition, right? If both the signs of the numbers is different and the operation is addition, you go by subtraction, right? Okay. So you require the relationship between the signs of the two numbers. Okay, whether the two signs are same or different. If the two signs are same, during addition, I have to perform addition of the magnitudes. Okay. If the two signs of the numbers are different during addition, then I have to perform subtraction of the magnitudes. Am I clear? Similarly,
Yes, ma'am.
if the signs of the two numbers is the same, during subtraction, I go by subtraction only. If the signs of the two numbers is different, during subtraction, I go by addition. Okay. So I require the relation between the two signs of the two numbers, whether the both are same or both are different. Okay, which hardware will gives me the correct result, whether the both is same, both the signs are same or both signs are different. Which hardware helps me to do so?
Multiplexer.
Yes, not audible.
Multiplexer.
XOR gate. One XOR gate you require. So whose output is 0 for both same inputs. The output is 1 for opposite inputs, right? So one XOR gate is required, exclusive OR gate, whose inputs are signs of the two numbers. So let us consider AS and BS are sign of the corresponding two numbers. A and B refers to the magnitudes of the two numbers. Okay. So this is the hardware required for implementing the algorithm on addition and subtraction. Okay. One parallel adder, two parallel subtractors, one comparator, one XOR gate. Okay. So, but there is another way to perform the same operations with the minimum hardware. Okay. See, usually how the subtraction is carried out by you. Usually, you can even perform the subtraction with the help of adder, with the help of addition, right? In what way? Rather than using two parallel subtractors, I can use a parallel adder along with what extra module you require to get subtracted output.
Not get complement.
Complementer, right? So I can perform subtraction by complementing the number and adding to the first number. Okay. So with the help of parallel adder and using a complementer, okay, by using one complementer rather than two parallel subtractor, the same parallel adder suffices for getting the outputs either A minus B or B minus A. Okay. And which complementer? See, if you choose a particular complement perfectly, if I suppose I'm using 2's complement method of subtraction, okay, 2's complement method of subtraction, while performing subtraction of two numbers, A minus B, right? See, I want to do A minus B. How I want to implement? By using the same adder only, parallel adder, but by taking the second element in its 2's complement method. Okay. So minus B I'll be getting by using the complementer. My complementer is using 2's complement method. Okay. So after performing addition of a 2's complement number with another number, okay, can I get which number is bigger? How can I justify without using the comparator? Can I get that my first number is bigger or lesser? Can I conclude from this result? See, ma, for example, I want to perform 6 minus 7. Okay. What are the magnitudes here? 6 and 7 are the magnitudes. What are the signs? 6, first number is having positive sign. Second number is having negative sign. Okay. Okay. Right. So
Yes,
this
ma'am.
I want to implement like 6 plus of minus 7. I wanted to implement in this way. Right. So rather than going directly, I will do minus 7 and then I will add that to 6. Isn't it? Okay.
Yes, ma'am.
I will take minus 7 and I will add that to 6. What is 6? It is 1, 1, 0. And what is 7?
1, 1, 1.
1, 1, 1 is 7. its 2's complement value. First take 1's complement and then add 1 to it. So then I'll be getting 0, 0, 1 is 2's complement of 7. Okay. So minus 7 is nothing but 0, 0, 1. Right? Now I have to add these
Yes,
two.
ma'am.
If I add these two, what is the result? 1, 1, 1. Okay.
1, 1.
Your result is 1, 1, 1. And do we get any carry? We didn't get any carry. So your
No, ma'am.
extra bit here it is 0. So there is no carry. So while performing 2's complement addition, if you don't get carry, what it means? 2's complement addition, if you don't get carry, it refers to result is negative, right? Isn't it? Forget about we are using sign magnitude form and all. Okay, the method that we are using here is 2's complement form. If one number is 2's complement and we are adding to another number, so we are using 2's complement addition. In 2's complement addition, if you don't get any carry, it means that the result is negative and it is represented in its 2's complement form. To get correct value, I have to 2's complement this value, right? So if I do 2's complement of this, 1's complement is all zeros.
1.
I have to add 1 to it. So I'll be getting 0, 0, 1. So magnitude is 1 and I need to put minus to it because I have complemented my data. So minus 1 is the result, right? Okay.
Yes, ma'am.
See, another example, if I want to see 7 minus 6, let us suppose. What is 7? 1, 1, 1. 6 is 1, 1, 0. It is 6.
1, 1, 0.
Now I have to perform 7 plus of minus 6. So minus 6 I need to do by 2's complement. 1's complement is 0, 0, 1 and I have to add 1 to it. 0, 1, 0 is minus 6 that I am adding here. Now add. So 1, 1, 0, 1, 0. Now I got extra bit 1 and 0, 0, 1. Okay. So whatever is here, extra bit, we need to have only 3 bits, but this we need this is what the result and this is what your carry. This one is extra. This one is extra carry, right? So
Yes,
while
ma'am.
doing 2's complement addition, if you got extra carry, it means that the result is positive and that extra carry we will neglect, right? So your result is now what? Plus 1. Isn't it? Okay. So this extra bit, whatever we are getting, okay, this will says that the first number is bigger or lesser than the second number, isn't it? See, if you are not getting any carry, it means that the result is negative and the first number is lesser than second number. If you are getting carry, means the first number is bigger than the second number. So without using even the comparator, without using, sorry. Sorry. Am I clear? So now you don't even require a comparator. If you perform complement and parallel adder, the extra carry whatever we are getting, that will says out of the 2 magnitudes which is bigger. Am I clear? So the reduced hardware is 1 parallel adder and 1 complementer, n-bit complementer based on the number of bits in your number, n-bit complementer, and what else you require? Nothing. These 2 are sufficient, right? Of course, an XOR gate is must for having the relation between the 2 signs. Okay. So these are only the required hardware for implementing addition and subtraction. So this complementer will give, we think that it produces 2's complement of the number. Okay, right? See, though our numbers are sign magnitude form, so it doesn't mean that we cannot use a complementing procedure of 2's complement in its algorithm. Okay, we can use this method. Okay, our numbers are represented in sign magnitude form. In that, we are using 2's complement addition. Okay, it is nothing wrong in this. Is it clear? So
Yes,
let's summarize this. Okay, so now we are seeing the algorithm addition and subtraction with sign magnitude data. A and B represents the magnitudes of two numbers. AS and BS represent the sign of the two numbers. Okay, see, if your numbers are of n bit width, A and B are of n minus 1 width, because AS and BS, the one most significant bit, we are separating as sign and we are using it separately. Excuse me, 1 minute. Very sorry, Amma. This work from home concept is very difficult for us. Okay, so if the two numbers are of n bit width, A and B, they represent the magnitudes of width n minus 1. AS and BS, which is of 1 bit width, that represent the signs. Okay, so now coming to the operations, we have 8 possible operations, combinations, plus A, plus of, plus B. So magnitude is plus of, add magnitudes here, because the operation is positive and both have signs same, that too positive. Okay, so result is addition of magnitudes, and resultant sign is sign of A. We'll take out of A and B, we'll take only sign of A for reference. Okay, next operation, plus A, plus of, minus B. Okay, the operation is A minus B if A is greater than B. And what is the resultant sign? Resultant sign is equal to sign of A. Sign of A will be the resultant sign, which is positive here. Okay, if A is lesser than B, you have to subtract the magnitudes, but it is B minus A. And what is the resultant sign? It is sign of B, which is nothing but negative. Okay, or else I can refer this as complement of sign of A, because my sign of A is plus, opposite is minus. Okay, in that way also I can conclude. When both are equal, the result is plus of A minus B, to assure plus 0 only. Similarly, third case, fourth case, and till 8 cases. Okay, I think this table is clear.
yes, ma'am.
Now Now coming to the hardware implementation. So as I said, I'll be having two registers or of width n minus 1 bit width A and B to hold the magnitudes of the two numbers, and two flip-flops that hold the corresponding signs AS and BS. Okay. And when after performing the operation, either it can be addition or subtraction, the result will also be of n bit width, most significant bit for sign, and n minus 1 bit register you require for holding the result. Okay. So rather than reserving one more register and one more flip-flop for the output, okay, I will reuse one of the register and the flip-flop to hold the result. Okay, because after the operation I may not need the inputs back. Okay, so for that, so I'm reusing a register A and its corresponding flip-flop AS for holding the register result. And a parallel adder I require to perform the micro operation A plus B. And I'm using a comparator circuit to establish the relation between the magnitudes A greater than B or A less than B or A equal to B. And the two parallel subtractor circuits I require to perform the micro operations A minus B and B minus A. One XOR gate to find the relationship between the signs AS and BS. Okay, so this is by observing the algorithm, the required hardware needed. Okay, hardware for implementing. But as I mentioned, the compressed hardware requires only one parallel adder. Rather than subtractor directly, I will use the same parallel adder, but complementing the second input. Okay, so my B register here and BS is a flip-flop. So this BS is a flip-flop for storing the sign of B, and B register magnitude for storing the magnitude of the second number. AS is flip-flop for storing the sign of first number. A register is n minus 1 bit width for storing the magnitude of the first number. Okay. And I'm complementing my B and given to parallel adder. So this is my B and here I am getting A. So here it will perform A plus B or A minus B. A plus B or A minus B it will perform. So I may give based on this input. Okay. So my input can be plus B or minus B. Okay, based on the mode control bit. Okay, so if my mode control bit is 0, if my mode control bit is 0, my input carry is also here 0. It produce no complement. For the complementer it is off output. Okay, so as it is B will be given for parallel adder, plus B I will produce. Okay, A plus B it will perform. If my mode control bit is 1, okay, if my mode control bit is 1, here 1 is given for complementer. So I will be getting one's complement of B here, and one more 1 based on the same M is added to it. One's complement and then 1 added, I'll be getting 2's complement value, right? That will produce you A minus B. Okay. And after performing this addition, whatever is the extra bit that is coming out, that we are reserving in extra one more flip-flop, which is E extra carry, output carry. Okay, right? So now this E bit will decide whether it is A greater than B or A less than B. So if E bit is 0, it is concluded that A is lesser than B. Now what is the sign of result? It is complement of sign of A. Because whatever is the sign of B, that will be given for sign of the result. Okay, so when they are opposite, then only I may need to perform subtraction operation as per the previous slide, right? So when the signs are opposite, then only I wish to perform subtraction operation. Okay, so the sign of the result is sign of B when A is lesser than B. For this condition, I will achieve E as 0. Okay, so it is nothing but complement of sign of A. Result is saved AS is complemented. Whatever it is, this register that is complemented if E is 0. If E is 1, whatever it is the sign of AS, that will be kept as it is for the sign of the result. Okay, result and summation will be stored in the register whenever I get the control of load sum. Okay, so this is the hardware implementation. Is this clear, this diagram?
Yes, ma'am.
So now we go by a flow chart. So whatever it is, the procedure that we have explained, that is available in this flow chart. So first number is A, which is nothing but adjoint, and second number is B, we call that as addend. Okay, A and B are the magnitudes. The corresponding number to sign is AS and BS. So now we are comparing the signs of the two numbers, AS XOR with BS. And this flow chart for add operation. So the operation is addition. If both the signs are same, the XOR output is 0. What operation you have to do? Addition operation. Okay. So while performing addition of the magnitudes, whatever is the extra bit that is coming out, we call that as addition overflowed bit. Okay. So that E bit will be saved in addition overflow flag, AVF. Okay. During addition, we are not complementing anything. We are just adding two magnitudes. If you get extra bit out of this addition, that is said to be the addition overflow bit. Okay. And this is for addition. It is finished. During addition operation, if the signs are different, the XOR output is 1. It means the signs are different. They are not same. And it says by the XOR output. So then what you have to do? You have to perform subtraction. How the subtraction is carried out? 2's complement addition, right? So we have to first calculate 2's complement of B as B bar plus 1, and that is added to A. So then I will be getting EA. In this case, addition overflow flag is 0, and the result is E and A. A is the resultant sum which is stored in A register back. Okay. So for result, I am using the A register for re-overwriting. Okay. And E, based on E, now you will decide what is the sign of the resultant. Okay. If E is 0, so during 2's complement addition, if you achieve extra bit as 0, it means that result is negative. So A less than B. We are doing A minus B here in this form. Okay. See, we want to perform A minus B. With this minus B is achieved by using B bar plus 1, which is 2's complement method. So in 2's complement method of addition, if you don't get any carry, it means that the result is negative. Result negative means A less than B. That's what the condition. Okay. So if A less than B, whatever is the sign of B, that will be taken for sign of the result. Okay. So sign of B is nothing but opposite sign of A, because these two are not same. So what is the resultant sign? Resultant sign is complement of the original A sign that we are saving. And what is the exact result? Result is negative and you need to do complement it. Okay, so hence I have first calculated 1's complement and then I have added 1 to it. Is that clear?
Yeah, ma'am.
Okay, so this is addition operation. So in addition, we have first checked this magnitude, sign bits. If both are same, then we just perform the addition of the magnitudes and whatever is the extra bit that we have stored in addition overflow bit. Right? If the signs are different, then you have to perform subtraction by using 2's complement method, and the 2's complement carry out will decide the sign of the result. Okay, whether it is the same sign or opposite sign. If you get a carry as 1, it means A is greater than or equal to B. Even for result 0 also, you will be getting a carry of 1. You can check this condition also. See, if I want to perform 7 minus 7, 7 is 1, 1, 1. Minus 7, I have to complement and then add 1. So 0, 0, 1. So minus 7 is 0, 0, 1. This I am adding here. 1, 1 is 1, 0. 1, 1 is 1, 0. 1, 1 is 1, 0. Okay, this is the extra carry. See, if the magnitudes are same, A equal to B, and you are performing 2's complement method of addition, 7 plus of minus 7. The minus 7 is calculated in 2's complement method and we are adding that. Even if the magnitudes are same, we will be getting a carry 1. Okay, so it is concluded that carry will be getting a carry of 1 if A is greater than or equal to B. Okay. So now what is the sign of A? It is same as sign of B, but that too, if magnitudes are same, you need to assure that the result is plus 0, not minus 0. Okay. See, now based on the magnitude of result, we will take the decision. If A is 0, then I will force my AS to 0. So getting a result of plus 0. If A is not 0, it means the result is not 0. Operation is already done in previously. Okay. So if A is not 0, it means something value is there. Based on the sign of A, that will be taken for sign of the result of AS directly. No manipulations are done on sign of A. Am I clear? The second case, when E is equal to 1. Okay, this is addition.
Yes, ma'am.
Now go for subtraction. So in case of subtraction, minuend in A, subtrahend in B. So I have to perform A minus B. Okay, based on the signs of A and B. So the signs here, AS and BS, I have performed XOR operation. And if both the signs are same, the result is 0. So you have to proceed by subtract side. If both the signs are different, I have to go by addition. Okay, so this is what the win. If both the signs are opposite, then you have to perform addition operation and extra carry will be in E. The sign of the result is same as sign of A or B. Both are same kada ikkada. Sorry, sign of A. Here the sign of result is nothing but sign of AS. Okay. Here if both are same and the operation is subtraction, I have to perform A minus B first. B minus B is taken for as 2's complement. And now based on E, I'll decide the sign of A. The procedure is same. Okay. Am I clear?
Yes, ma'am.
Now combine these two. This is what the flow chart for addition or subtraction operations for sign magnitude data. Okay, the operation, it can be addition or subtraction. In case of addition, the terms are again and addend. In case of subtraction, the terms are minuend and subtrahend. In both the cases, I will compare the signs. In case of addition, if both the signs are same, then addition is carried out. If the both signs are different, then subtraction is carried out. In case of subtraction, if the both the signs are different, then addition is carried out. If both the signs are same, then subtraction is carried out. And this is how the result is updated. Okay. So this is for addition and subtraction, and this is what the hardware required. This is 2's complement. Sorry, the hardware required I have already mentioned previously. 2 registers A and B for storing the magnitudes, and 2 flip-flops for storing the signs AS and BS, 1 parallel adder, 1 complementer, and 1 extra carry bit, E bit for storing E bit, and one more flip-flop for storing addition overflow flag. Okay, this is the hardware required for sign magnitude implementation. Okay. See, it is not just learning the hardware, the flow chart. You need to illustrate this with the help of example also. Okay, so example will be seen in next class. Okay, I have to take 2-3 possible conditions, and I need to explain with the help of example. Need to follow the same flow chart, same steps, and you have to get your proper result. Okay, so example we'll see in next class, followed by 2's complement data, addition and subtraction with signed 2's complement data. Okay, is this clear? Any doubts? Okay, see, I am following the same textbook, which is Maurice Mano, Computer System Architecture by Maurice Mano. In that we have these algorithms, including the examples. You can refer the textbook, or else anyway I'll upload the flowchart also for your reference. I mean PPT also in your learning portal for your reference. Okay. Yeah, meanwhile, I'll collect the attendance. If you have any doubts, you can ask me. "67 absent, 69 absent, 79 absent, 82 absent, 100, 101, 102, 104, 109, 110, 113, 115, 120, 312 absent. Absentees are 67, 69, 79, 82, 100, 101, 102, 104, 109, 110, 113, 115, 120, and 312. Okay, Ma. Thank you. Bye for today.
Thank you, ma'am.